Hi, in this video, we're going to talk about chapter 2, inertia. Let's go into the, first I'm going to define inertia. Yeah, inertia. So Galileo had a big discoveries, and one of his big discoveries, besides that, he mentioned that an object of a different weight falls at the same rate. So that one's he prove that mass doesn't matter for objects to fall at the same speed. They neither, regardless of a mass, every objects fall at the same rate without friction when it's not an influence under air resistance. But another big discovery that he did was about inertia. So when you put the ball on a flat surface, the ball stop rolling, stop moving. It's because there's a friction force. But as soon as so it stops moving. So there's a force applied to stop the ball. But when the ball is rolling and you're no longer in contact with the ball, right? So there's nothing is touching the ball. And if the ball is completely flat, and if there's no friction, the ball is going to keep rolling with the same speed in the same direction. If there's no friction and in a complete flat surface, the ball is going to keep rolling. Is there any force that's applied for the ball to keep rolling? You're not touching the ball anymore. So there's no more push force, right? But in a complete surface, a complete flat surface, there's no gravitational force, changing gravitational force either. So you don't have anything. He said it is due to the property of inertia. So all the matter has inertia, that property that it resists in changing motion. So once it's at rest, it wants to stay at rest. And once it starts moving, it wants to keep moving with the same speed in a straight line. So let's write down the inertia. So one of the Galileo's discovery. Galileo discovery assess a moving object means no force to keep it moving in the absence of air resistance or any other resistance. And this is, so no need, right? So there's no need to have no force is needed. And the definition of inertia here, this is the inertia. It is the property of matter to resist changes in motion and depends on that actually how much you can resist the change in motion. That actually depends on the mass, on the amount of matter in an object. So it's pretty much the property of mass. The bigger mass you have a bigger inertia that you can more resisting motion. And the smaller one has a little smaller inertia, right? So when you have a ball, so applying the idea of inertia, when you have a ball that's on a flat surface, completely flat. No slope, right? And you have a ball that's already moving. This is already moving. And if it's completely frictionless, this ball is going to keep moving. Does it change the speed? Does the speed change? No. It keeps moving in the same way. There's no push force here. So once it's moving, you don't have to have a push force. It just keeps doing what's doing. And this is called the law of inertia. And Newton put all this idea nicely together, and he rewrite it. That says Newton's first law of motion. So this is it was the Galileo's discovery, but it is Newton put the idea and made it more sophisticated. And he said this is the first law of motion. It's a restatement of the concept of inertia by Galileo that says that so this is the first law, you gotta know this. This one you need to know. Every object continues in a state of rest or of uniform speed in a straight line unless acted on by a non-zero net force. Very, very important. So memorize it, and you need to know this by heart. It's the first Newton's law. Every object continues in a state of rest. So when the object is at rest, it wants to keep staying at rest. And then if object is moving with a uniform constant speed, it wants to keep being in the same speed in a straight line, unless acted by a non-zero net force. When you have a sudden change in motion, inertia is a property to resist in that motion. So that's the Newton's first law and the law of inertia. Let's see. I can. share my PowerPoint slideshow. Okay. So Galileo's concept of inertia is that don't worry about the force right now. It's that inertia is a property of matter to resist change in motion. And how much of inertia the object has, that will be depends on the mass. So the bigger the mass, you have a bigger inertia. It can more resist in changing motion. So when we have a ball that comes to rest when it's moving in a completely flat surface, that's due to friction, right? That's due to friction. It's not due to, but if there is no friction, the idea that's amazing is that he thinks about what if there's no friction? Then it actually is going to keep moving. Nobody's pushing anymore. It's not sliding down or going up. So there's no gravitational force or anything. Why does it keep moving in a straight line if there's no friction? And that's because of the law of inertia. Just wants to keep doing what's doing. You don't need to know this part. We're going to do this one later. So let's see. I have a video that I can share with you. Here. So here, how do I share this? Let's see. Share this with you. I believe it's this one with the sound here, right? So here, use my family for a demonstration. This little boy is on a skateboard. So he's on a skateboard, and then I have a blanket. So that when he goes on a blanket, there is going to be a friction force that applies. Okay, so let's see.
You go right here.
Yeah, stopped.
Stop.
So you see that once it reaches the friction force is there to stop. This is what we know. Friction force is there to stop. Have another one. I had it be even. Here. Again, the similar, same thing. You change your person.
It may stop.
You may stop.
Whoa.
Stopped.
Stop.
Right? Friction force is there to stop the motion, right? But what if there is no friction force, or rather minimum friction force, right? Here. So here. So now I remove the blanket.
What's this? Sugu, what's this?
You see that he keeps moving. Once it's released from my husband's hand, right? He's no longer in contact with anything. And then if the ground is perfectly surface flat, then there's no forces applied to keep him moving. So that is the property of inertia. Once there is no more friction, it keeps moving in the same speed in a straight line. Here's another one too. All right.
Nobody's pushing now. So what is this?
Inertia.
Inertia.
So that's the inertia, right? The the property of inertia that says that it keeps moving unless acted by no changing force. I also usually do this magic trick in a class. Let's see. So I'm going to share the screen first. All right, so there is a little mermaid Ariel. I hope that Disney won't sue me for this. I have a Ariel here, the Ariel doll on the table, and I'm gonna pull that paper really fast. What happened to Ariel? And my magic trick is that Ariel won't break or won't fall. Typically, I don't have a courage or practice enough to do this with my nice crystal wine glass that has an expensive wine in it. So unfortunately, my daughter has to sacrifice her favorite doll. So I have to do it for the sake of my doll, and you guys have to wish me luck on this and see what happened to this little toy mermaid.
Okay.
Okay, like that. What do you say? It's a success, right? And here is a slow-mo of the doll at a different time. Okay, here. So the doll was saved, right? It wants to say where it's at. So even though there's a big change, it resists that motion that it wants to say where it's at. Okay, that is the, so you see that's the property of inertia. And I want you to memorize or just know this by heart. What is the Newton's first law? I want you to be able to say what's the Newton's first law. Is that every object continues in a state of rest, or it's in a uniform constant motion in a straight line unless acted by a non-zero net force. Then it's going to change its motion. But when it also, if it's suddenly acted by a motion, the net force, then inertia is a property to resist the changing motion. All right. So that's it for the chapter 2, part 1 about inertia. See you in a class.